Hey guys, welcome back to Chemicals TV. In this video, let's focus on the concept of inductive effect. And inductive effect is one of the most confusing topics in organic chemistry. So in this video here, I want to look at the everything about inductive effect, definition of inductive effect, and how to understand the definition of inductive effect. Then I want to look at type of inductive effect, the power of inductive effect. Then I want to look at various examples. So let's dive into it. First of all, what is inductive effect? There are two key definitions I want to give to you now. Then I will later go on and explain those definitions. So, what is inductive effect? Inductive effect is the polarization of one bond caused by the polarization of adjacent bond in a molecule, or it is the effect in which an atom or group has on the neighboring site virtue of its electronegativity. You may not understand that definition now, but you need to copy that definition, this definition, into your notes. As we move on, when I explain the two concepts I'm about to explain, you understand it better. Do you get that? Because in the exam they will ask you any of these definitions. So for you to understand these two definitions, you need to understand two key things. First, for you to understand what's called electronegativity, and to understand what's called polarization. Do you get? If you can understand these two concepts in organic chemistry, then you should understand what's called inductive effects. So in chemistry, electronegativity is the ability of an atom to pull electron to itself in a covalent bond. Now let me explain that for you to understand. See, imagine you have two scenarios. You have A and B. So the ability of an atom to pull electron to itself in a covalent bond is called electronegativity. Now, when you see a covalent compound, there are two things that will happen there. That compound can either be a polar compound or a non-polar compound. So now let's start with one here. Let's imagine that A and A, they are the same atoms. Do you get that? They have the same electronegativity. Do you get that? So because they are sharing the same bond here. Remember, this is a bond here. It contains two electrons. A bond contains two body electrons, right? So in a covalent bond, you are involved with the sharing of what? Of electrons, just like hydrogen and what? Hydrogen. What happened here? This one will donate, this one will bring, this one will bring. What will happen here? They now form a covalent bond. Do you get? So this one is also the same thing as what? Do you get? So in organic chemistry, you are actually talking about a covalent bond. So let me write some out. So if, for example, here we have this compound here that contains A and A. So I'm going to use A and A to illustrate that these two have the same electronegative what power. Now, because these two have the same electronegative power, what happens here? They have equal pool of the bonding electron. Now, when they have equal pool of the bonding electron, they will share the bonding electron what equally. Now, this one will have the same strength of pool of the electron as the what other one. Now, whenever a covalent bond is having atoms of the same or nearly equal electronegative power, now that kind of compound is called non-polar bond. Non-polar bond. Now, the bond that is between atoms of the same electronegative power is called non-polar bond. This bond is called what? Non-polar bond. And the compound that contains or that carries atoms with the same electronegative power is called non-polar compound. Non-polar compound. Do you get? A good example is when you have example of non-polar compound is what? H2. Then this one contains two hydrogen. So two hydrogen have the same electronegative power. So whenever you see H2, H2 is a covalent compound. It's called non-polar compound because hydrogen have equal pool of electron. Another example was Cl2. Now, it's just chlorine and chlorine, so they have equal pool of what? Of the electrons. It's called non-polar compound. And the bond that exists there is called non-polar bond. You get? Another example is what? CH4. Now, carbon and hydrogen have nearly equal electronegative power. So the bonding electron will be shared or pulled equally by carbon and what? Hydrogen. So now whenever you see an hydrocarbon, hydrocarbon that is carbon and hydrogen. Whenever I see an hydrocarbon is always what? Non-polar compound. Non-polar compound. Example is what? Is the methane. You get? Example is the methane. Another example is what? Is the benzene ring. Six is H what? Six is what? Benzene what ring. As long as it contains only carbon and hydrogen, they are what? Non-polar compound. No matter how heavy it look like, it's called non-polar compound because the atoms that form that compound have what? Nearly equal electric what? Negative what? Power. Do you understand? So in organic compound, the covalent compound can either be non-polar compound. Now, when it's a non-polar compound, it means that the atoms from that covalent bond are having nearly or equal electric what? Negative power. So the bonding electron will be what? Shared equally between what? The atoms. These are examples here. Do that. Now, but our main focus to understand inductive field is going to be for no for what? Polar compounds. That is atoms with what? Different electronegative what? Power. So if for example here I have this compound here. If for example I have this compound here, A bond with what? B. Right here. So this is what the bond. It has what? Two bonding electrons. Now let's imagine that two of them do not have equal electronegative power. One is higher than the other one. Now let's imagine that this is higher than this. Now because electronegativity is the ability of an atom to pull electron to itself in a bond. So when two atoms forming a covalent bond want to break, now if one have more pull of the electron than the other one, that is what up here, more of the bond electron will what? Will pull. Sorry, if one have high electronegativity than the other one here, that atom will tend to what? Pull the electron more. So if this guy have greater pull of the electron, that is high in electronegative what? Power, what will happen here? More of the body electron will pull towards what? B, because B is higher in what? Electronegative power. Imagine in a tug of war when two sides are pulling a rope. Do you get the strongest side will pull more of the what? Rope, right? The same thing here. So if this one is high in electronegativity, and here is what? Low in electronegativity. Right there. Now this one is high in what? This one is high in what? Electronegativity. And this one is what? Low in electronegativity. The body electron will not be pulled equally. Hope you understand. So this one will not become partially what? Negative. So the side that pull more of the body electron will become what? Partially negative. While the side that lose the electron become partially what? Positive. Now when this happen, a dipoles are what form. So partially negative or partially what? Positive. So when this guy pull more of the body electron away from this other one, you say that polarization has occurred at this point. Right there. So this bond is called polar bond. Polar bond. And polarization has occurred. Right there. Polarization has occurred. Do you get that? So this bond is called polar bond. The compound that contain atoms, the covalent compound that contain atoms with different electronegative power, the compound that contain atoms with different electronegative power is called polar compound. Polar compound. Polar what? Compound. Do you get that? So the whole of the compound is called polar compound. The bond that have atoms with different electronegative power is called non-polar bonds. And when this atom pull more of the bond electron, we say polarization has occurred. So in the sense that electronegativity and polarization occur, do you get that? Polarization only occur when there is difference in electronegative power. When there is what? Polarization only occur when there is what? Difference in electronegativity between atoms forming a covalent what? Bond. You need to put this thing in mind because these are the key concepts you really want to understand when it comes to what? Inductive what? Effect. So if I should write on here, what are the examples of non-polar? What are the examples of what? Polar bonds? A good example of a good example of polar compound is what? HCl. Here we have HF. Here we have CH2Cl. Do you guys? Here we have H2O. Here we have NH3. Now, these are examples of what? Polar compound, polar covalent what? Compound. Do you get that? They have atoms with what? Different electronegativity. Do you get that? So, with understand now, let's go ahead and explain inductive effects. Now, let's go ahead and understand those definitions. So, if for example here, we have CH3, CH2, H. Remember, now this H, this one is also the same thing as CH3 or CH what? 2, right? The same thing. Now, this compound is called non-polar compound because it only contains carbon and what? Hydrogen. Carbon and what? Hydrogen. So I will write one here. So now this H here can be anything. Remember, when I have something like this H or hydrogen do not have any electronegativity. Do you get that? The electronegativity is what is very, very what? Low. Do you understand? Now, these two carbon atoms are the same. Carbon A and what? Carbon what? B. Do you get that? Carbon A and what? Carbon B. But what happens when a chlorine is removed? What happens when that hydrogen is being removed and you be replaced by what? Chlorine. Now, what will happen here? This is what will happen here. Here we have carbon, hydrogen, and what? Hydrogen. Then we have hydrogen, here we have what? Cl. Do you get that? Now, chlorine is directly connected to what? To what? Carbon. Hydrogen. And this carbon is directly connected to this carbon here. Now, if there's hydrogen here, now this compound is said to be what? Non-polar compound because carbon and hydrogen have the same electronegativity. But for instance, if this hydrogen is now being replaced by a chlorine, chlorine is higher in electronegativity, right? So instead that chlorine will not behave like what? Hydrogen here. Why? Because chlorine what? Will pull more of the bonding electron away from this carbon here. Do you get that? Now according to be partially what? Negative. Do you get that? Now remember at this point here, these two carbons are the same, right? But when chlorine pull electron away from this first carbon A and what? B, A and B. Now, because chlorine have stabilized this carbon here, do that carbon A and carbon B are no longer the same. Remember, when chlorine pull electron away from carbon, polarization has occurred here, right? Now, carbon A is now slightly more electronegative than what? Carbon B. So what happened here? Because this guy, electron has been pulled away from it. Now this guy want to compensate carbon A want to compensate itself. Now what is he going to do? He's now going to pull electron away from this what? Carbon B. What happened here? Electron will be pulled by what? Carbon B from carbon A. Do you get that? So but you have to understand that this guy pull electron from A will also pull electron away from what? B, but not as much as what? Chlorine pull electron from Juliet. So because this guy is now slightly more electronegative than this carbon B, what happen here? Electron what will what? Push towards or carbon A will what? Pull more of the bonding electron between carbon A and what? Carbon B. Juliet. So polarization will also occur at this point. Now, what actually causes this polarization here is due to what? This electron withdrawing group. Do you get that? So chlorine is what's called electron withdrawing group. Instead that in some group are what? Electron withdrawing. because they are what they are in electronegative what power. Do you get that? So if this guy pull more of the bonding electron away from carbon A will pull the bonding electron away from carbon B, but not as much as the A C pull electron away from this other one. Do you get that? So you can see that that is how inductive effect will what keep on moving until it dies off. Do you get that? So in the sense that with this one here, you can see that inductive effect is the transmission of polar effect through sigma bond. This is one of the definitions you need to understand. Inductive effect is the transmission of polar effect through sigma bond. And here is that the polarization of one bond. Now, instead that the second bond is caused by the polarization of what of this what first bond. So that breaks down to the first definition I gave to you. I said that inductive effect is the polarization of one bond caused by the polarization of what adjacent bond in a molecule. That is also the definition of what inductive effect. Or I say that it is the effect in which an atom or group has on the electron density at a neighboring site, virtue of its what electronegativity. So if you look at chlorine here, chlorine pull electron away from this carbon here because it's what high in electronegativity. Do you get that? So it has what reduce the electron density in what carbon A. Do you get that? Virtue of its what electronegativity. It is the effect in which an atom or group has on the electron density. So chlorine will what pull more of the electrons by decreasing the electron density away from carbon A. Do you get that? For carbon A to compensate itself, you have to what to withdraw electron away from carbon B. So this is how the polarization what occur here. So you need to understand these three key definitions. So if you understand, say understood, and you're following up the class, if you have any questions, you can also drop it at the comment section. Please, if you have anybody that want to watch this video or want to be part of this class, please share the link to that person and tell the person to join this class. So I really want to hear from you. So with this definition now, and with the explanation, I believe you understood what is called inductive effect. So the three definition is that inductive effect is the polarization of one bond caused by the polarization of what adjacent bond in a molecule. Do that, or it is the effect in which an atom or group has on the electron density at a neighboring site, virtue of its what electronegativity. Idea, or you can say inductive effect is the transmission of what polar effect through sigma what bond. Do you get? So, but before we look at type of what inductive effect, there are some key features of inductive effect you really need to pay close attention to. Now, what are the features of inductive effect? So let's look at what the features of inductive effect. They are already on the board. So please make sure you write them. Sorry for my handwriting. My handwriting is not fine, but I believe you can see them. Right? So it arises due to electronegativity difference between the two atoms form a sigma bond in a covalent bond. Do you understand? So inductive effect is due to what? Is due to what? The electronegativity difference between the atoms forming the what? The covalent bond, which I've explained before. Number two, the transmission is through sigma bonds. Do you get? It is the transmission of polar effect through sigma bond. That is alkanes. You get? That is number two. Inductive effect is the greatest for adjacent bond, but may also be felt by carbon atom further away, about three bond away from the electronegative what element. Do you get that? So remember, inductive effect is the transmission of polar effect through sigma bond. So as it move on, the effect is what is it dies off. That is, inductive effect is felt most by the adjacent atom close to what to the what electronegative element. Do you get that? So as you move along, it dies off about what three carbon atoms along what the chain. Do you understand? Then number four, the magnitude of the inductive effect decreases while moving away from the group or atom. You understand that? And it influences what the chemical and physical properties of what of the compound. Immediately you introduce electronegative element to the compound. What happens here? It stabilizes towards the compound. It affects what the physical and chemical what properties. Do you get? So these are what the key features of inductive effect you need to take note when looking at what inductive effects. Hope you understand. So make sure you pause the video and take these things down. The next one I want to look at is what type of what inductive what effects. So let's look at what types of inductive what effects. Basically, there are what two types of inductive effects. Like for example, here we have this one we did here. I put what chlorine. Do that. I will add chlorine here. Chlorine remove electron item. So it means that chlorine is what minus I effect. Do that. Those electrons that withdraw electron or decrease the electron density in the molecule are called minus I effect. Then we also have some other group that what instead of them remove electron, they increase what electron. So that's why we have what positive inductive effect. Now, whenever I say plus I effect means what positive inductive effect. The plus I means what positive. The I means what inductive what effect. Do you get that? So what is plus I effect? These are atoms or group that increases electron density in a molecule. Do you get that? So any species that tends to what increase electron density instead of withdrawing. Do you get that? They are called positive inductive what effect. Do you understand? So these are various positive inductive effects we have. The common one I want to see this. It means that the more the alkyl group, the higher what the plus I effect. Do you get? So here we have this one here. This one is just like OH. Now this O here, I've lose hydrogen here. Then comes one. Do you get? Then this one just like um so this one I've lose what hydrogen from this other one. Do you get? Now this one I've lose hydrogen. Do you get? So in the sense that when you see this one here, you know this one has higher tendency to push electron or to donate electron more or increase electron density more than this. Because this is what highest, this is what lowest. As a matter of fact, hydrogen is what has zero inductive effect. So from here, this one is the highest, followed to what this, then this here. Now the one I want to use more in this video and the one I want to see more in your exam is this one here. Consider that this character is carrying what 3 methyl. So this one is called tertiary alkyl group. Do you get tertiary what alkyl? Because this character is carrying 3 alkyl here. So here going to be tertiary carbon. Now the one that carry 3 carbon is higher in electron in what in plus I field than the one that just carry 2 carbon. The one that carry one, the one that just one, the hydrogen. Do you get that? So from here to here is decreasing. This one is higher than this one is higher than this. So if you move from highest to the lowest, highest to the what lowest, just like when you have 5, 4, 3, 2, 1. Highest to the what lowest. So 5 is greater than what 4, 4 is greater than what 3, 3 is greater than what 2, 2 is greater than what. So from the highest to the lowest, it's called what? It's called decreasing order. It's called what? Decreasing order. It's called what? Decreasing order. Decreasing order. Do you know the reason why? Because you are moving from highest to lowest. Because most times you say rank there in increasing order of what? Of plus I effects. And any of this can be given to you. Do you get that? Rank there or arrange there in increasing order or decreasing order of a plus I effects. So if I have something like this, 1, 2, 3, 4, 5. So many people, so many students have issues to rank in order of increasing or decreasing. So that should not confuse you here. This is what I'm going to explain to you. When we move from 1, 2, 3, 4, 5. From here, 1 is less than 2, 2 is less than 3, 3 is less than 4, 4 is less than what 5. Do you get that? So from here to here is what increasing, is what increasing order. So in saying that 1 is less than what 2, 2 is less than what 3, 3 is less than what 4, 4 is less than what 5. Hope you understand. So it's called increasing what order. Yeah, but when you look at 5, 4, 3, 2, 1. 5 greater than 4, 4 greater than what? 3, 3 greater than what? 2, 2 greater than what? 1. From here to here, it's called decreasing what? Order. So you can see how easy it is here, right? So you need to understand this order here because any of this can be given to you in the exam. Say arrange them what in increasing or decreasing order of what plus I what effect. I believe you now understand what we call plus I effect. Plus I effect group. This is a group that what increases electron density in a molecule. Do that. So they are called electron donating. Do that. They are called what? Electron donating. They increase electron. Do that. That's what it's called plus I effect. And these are what the various what various groups that are what plus I effects. But in their order, hydrogen has zero inductive effect. So in the sense that when you see something like CH3, CH2, and CH3, I get. Now, the more the cover atom, the more the plus I effect. So now we compare the plus I effect between these two things here. This guy is greater than what this guy. Do you understand? So these are what basis to understand what is called inductive effect. Let's move towards negative inductive effects. So let's look at what the negative inductive effects. Now we have already looked at negative inductive effects. You can see that chlorine is negative inductive effect, so it's part of it. But chlorine is not only the what negative inductive effect we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 70. Do you get? So what is what negative inductive effect? These are electron withdrawing atoms. These are atoms that will decrease electron density in a molecule. So those atoms that decrease electron density in a molecule are called negative inductive effect, and it's denoted by what? Minus I effect. So most times we're going to use minus I effect and what? Plus I effect. Plus I effect is what? Is the positive inductive effect. So those are atoms that what? Increase the electron density or donate electron. One negative inductive effect is what? Minus I effect. These are atoms that decreases electron density in a molecule. They withdraw electron from the molecule. Do you get that? And here are what the various minus I effects we have, group we have here. Here we have the nitro group, here we have the sulfur group, no, the sulfuric group, here we have cyanide group, here we have iodine, here we have ketone, here we have carbonic acid, here we have fluorine, chlorine, bromine, iodine, and here we have what the alkoxy group, where we have the hydroxy what group. Here we have the alkyne, here we have the amine, here we have phenyl. Here we have phenyl, here we have what? The alkene. Hydrogen is what is the least. You get so you know the word pay close attention. You know that this is the highest, this is what is lowest. So once you want to put it in your mind that from the highest to the lowest, it's called what decreasing what order. So what you want to pay close attention is this one here, the halogens. You need to what take this order one here. Then you need to pay close attention to this and what phenyl. We are going to use all these ones. What now when it comes to what? Now when it comes to what application of inductive effect, I want to make use of this stuff here. Do you get that? So you're going to pick attention because in the exam, 4 or 5 of them will be given to you, or 3 of them will be given to you and say arrange it what in increasing or decreasing order of what minus I effect. You should be able to what to do that. So that's why you must master this thing here. Do you understand? So copy the guy inside your notes and make sure you take every definition I've given to you because you always see them in the exam, depending on your exam. Because some organic chemistry exam are what subjective, while some are what are theory, while some are what objective. So you know to what master these ones here. So if this video is helpful and you are following this video, if you're not subscribed, please endeavor you subscribe to this channel and share the link to your friends. Comment in the comment section that you're actually getting value in this video. It goes a long way to tell me that you watching this video, you're actually getting value from this video. Do you get that? So let's move to some questions when it comes to what inductive what effects, so you understand better. So let's look at the first question. This question I'm about to explain this video here is just to what know how to identify plus I and what minus I effect in a compound. You get that? So that is the essence of this one. But in my next video, this is where I want to talk about the application of inductive effect. You don't want to miss out. Make sure you subscribe to the channel so that you don't miss that video. Now, they say that for each of the following compound, detect the one that is what minus I and what plus I effect. So here we have A, B, and what C. Now if you find that they all have the same cyclopentane ring. Do you get that? The only thing that differs is this group attached to it. Right there, this group was attached to it. So OH is in what is in what? Is it plus I effect or minus I effect? If you check what the what type of inductive effect I gave to you, the plus I effect and minus I effect, you find out OH is what minus I effect. And minus I effect, they withdraw electron away from what molecule, right? So because OH is minus I effect, this compound is called minus I effect. Do you get? This compound is called minus I effect because OH is what minus I effect. Do you understand? This one, O minus is under what plus I effect. If you check it very well, check your power of what plus I effect. As a matter of fact, is the first one. So it will be plus I what effect. So you can see that this compound is what plus I effect. You get? Why this one here is carbonic acid is under what minus I effect. So here is minus I what effect. So the compound is what minus I effect. As easy as that. So let's look at what question 2. So let's look at what question 2. Probably this is going to be the last question I want to do in this video. To get that. But remember, I told you that in my next video I want to look at what application of inductive effect, and this is where bunch of your questions will be coming from. Do that, so you really don't want to miss out. So they say detect the carbon atom that is what plus I and minus I effect in the following compound. I'm going to do A, B, then what try C. You leave C for me at the comment section. Do that. So when you look at this compound here, remember carbon, I tell you that when carbon and carbon are connected, maybe here we have CH3 and here we have CH3A, right? Carbon and carbon that are the same. They are what? They are the same. However, they have the same hybridization. They have what? The same hybridization. Here we have sp3, sp3. Now, if you are here or you are watching this video and you don't understand what called hybridization or how to identify the sp3, the sp2, or sp, or I say I'll be issued those little chemistry topics, then I will leave the link in the description below where you're going to watch hybridization videos, the full videos, and exam style question video. Do you get that? It's very important to know these key things here because they will help you to understand this concept. Do you get it? So, but if you look at this one here I can say I can divide this component into what A and what into what B. You know the reason why? Now because these two carbons have what the sp, they have a triple bond. So this part here is what sp, right? Why is it sp? Because these two carbon atoms contain a triple bond. Do you get that? Then when you look at what the B side, now these two carbon atoms they carry what a double bond. So here you have what sp2. Do you get it? So the hybridization of the carbons are not the same. Now remember, from the power of minus I effect I give to you, you check it very well. Now you see sp, that is a triple bond before what a double bond. That is sp3 is higher when it comes to what minus I effect. Do you get that? So if for example here we have H and what Cl, automatically one is what plus I and one is what minus I. Do you get that? So this one that withdraw electron from this hydrogen is called minus I what effect. Why is that lose the hydrogen? This guy that lose what that withdraw electron is called minus I effect. Remember those species that withdraw electron, this electron density is they are called what minus I effect. So chlorine is what minus I, while hydrogen is going to be what plus I. So when our two things combine together and they have different electronegative power, one is what higher in what in electronegative than the other one. That is now going to be what the minus I effect. Why the other one now become plus I effect. So when we look at what the power of minus I effect, now sp is higher than what sp2. Turn to your notes, you understand that. So you can see that this one will come first. You see it before you see this one here. Right? So in the sense that because this carbon here, this portion of A is what sp, right? Here and here is what sp2. So what will happen here? This one is going to be minus I what effect. So this carbon atom, you say the carbon atom that is what plus I and minus I. So this carbon atom, this region here is what minus I effect. While this one is going to be what plus I what effect. Do you get? So do you see the reason why you need to what understand and master the plus I effect and minus I effect group I've given to you. It's very important to do that. And secondly, we are going to use that in application of what inductive effect. You don't want to miss that video. So let's look at this one here. If you check very well, let's say this one is what A and here is what is B. You get now this carbon is what sp3. Everybody smart. This carbon is what is sp3. This phenol here, they have what double bond is what sp2. Now sp2 is greater than what sp3. Do you get that? So what will happen here? Here going to be what minus I and here going to be what plus I. You get, so you do this last one for me. And then let me just say here is what is A and here is what is B. So comment at the comment section which one is what plus I and which one is what minus I. Comment at the comment section. Which one is what plus I? Is it A that is plus I or minus I? Or B that is plus I or what minus I? Leave your answer at the comment section. Do that. I hope this video is helpful. I have actually gotten value from this video here. You now understand what is called the inductive effects and how it works, right? If you understand, please say understood in the comment section. Do that and drop your answer at the comment section. Thank you for watching. You can check out this video on hybridization if you want to master hybridization. See you in the next video.